Hi, your rates. It's your next revision video for the summer assessment. Now, I'm going to go through this at quite a pace because I've already produced the video on section 10.2 energy transfer in reactions, and that's already on the YouTube. So if you need to have more time with that topic, may I suggest that you watch that video as well. That's in your Year 8 Chemistry playlist. So find the playlist on YouTube and you should be able to spend more time on this. But essentially what happens when chemical reactions take place, one way to prove that a chemical reaction has taken place is to identify a change in temperature. And some reactions release heat energy while others take it in. So some reactions release that store of heat energy to its surroundings, and other reactions take in that store of energy within the surroundings and they absorb it into themselves. Now, some chemical reactions have such dramatic energy changes that we actually observe explosions occurring. So I wanted to spend a little time emphasizing a few points because these were the points that perhaps people were a little bit stuck on. First of all, make sure that you know what the difference between exothermic and endothermic is. So an exothermic reaction is a chemical reaction that releases its stored heat energy to its surroundings. So that means that the surroundings get warmer and a thermometer would increase in its reading. The endothermic reactions that can take place in chemistry do the opposite. They absorb the energy in the surroundings, including the energy that may be stored inside a thermometer. So the thermometer reading would go down because it's losing stored energy. Okay, so here's a picture just to show you what happens when an exothermic reaction takes place, and here is another picture to show you and represent what actually happens when an endothermic reaction takes in energy. So the mixture actually feels cold and the thermometer reading would actually shoot downwards. Okay, so there was another point that came up when we were going through this in online distance learning, and people were not appreciating the reasons why when we do experiments that monitor energy changes, we must take steps to insulate the beaker to reduce energy loss. Because what then happens is you could actually have energy coming in through the sides, and that could cause an inaccuracy in using a thermometer, because you might actually not read the correct changes in energy between the actual mixture that's reacting and the surroundings. Similarly, if we had a very warm reaction, if we had an exothermic reaction, this keeps all of the heat energy that's released by the reaction mixture inside the actual container. So there's a higher likelihood, a higher chance for us to find more accurate measurements when we're reading, when we're trying to figure out and calculate energy changes. And one well-known way involves using a thermometer with a set mass of reactants. So we do need to make sure that we accurately measure the thermometer and we actually accurately measure the thermometer, but we also need to make sure that the thermometer is accurately measuring the changes that are taking place inside an exothermic reaction or an endothermic reaction for this very reason. So when we're doing energy change reactions, we must make sure that we've got some level of insulation around the beaker if it's a glass beaker, or if we can, as an alternative, we can use a polystyrene cup for our experiments. We must make sure that we try and put a lid on it to keep all of the changes in energy in between the system, which is the actual reaction mixture, and its surroundings. We must make sure that that stays intact. So the second thing that I'm going to talk about, I have talked about this in the videos that I've made, is that photosynthesis is an example of an endothermic reaction because it absorbs the radiation, the sunlight, and that's energy being transferred. And also glow sticks, which you see at parties and celebrations, they produce light when the chemicals inside react together, so that would be an exothermic reaction. And a final point for the top learners, this was a very challenging one for quite a few people. When you have two steps in a chemical reaction, you have bond breaking, which requires energy. So that's when you dismantle what you have as reactants at the start. And then there's a second stage where you actually make bonds, and that's where your new products are made, and that's exactly how a chemical reaction takes place. So this step over here where you have the dismantling requires energy, and this step over here requires energy to be released. So this is an endothermic step, and that over there is an exothermic step. Now sometimes the energy that's required is greater than the energy that's released. Now if that's the case, then overall your energy change is endothermic. If your energy required is less than your energy released, that means overall you will be releasing energy. You'll use some of that energy to pay for the bond breaking, but you will get a total energy that is being released. So for that would be the pattern we see with exothermic chemical reactions. Okay. And the reason why we actually get that is because not all bonds are actually the same strength. They vary in how much energy is required to make them and to break them. As a chemical reaction involves rearranging atoms, the type and number of bonds broken will not be the same as those that are made. Okay, we've actually got 1, 2, 3, 4 bonds that we are breaking here, but 1, 2, 3, 4, 5 bonds that we are making on the right hand side. This is a good representation of reaction between, for example, potassium and water. So potassium reacting with water is quite an exothermic reaction. The bonds between the hydrogen and oxygen atoms in the water molecule have to be broken, and the new bonds that have to be formed between the potassium and the oxygen, so that's one type, and then you've got the oxygen and the hydrogen, which is the potassium and the oxygen, and then you've got these ones stay intact. If you wanted to, you could separate them out, but you know, when you're doing calculations, you can actually assume that this one is intact. So a nice little shortcut we take in GCSE, but that's for next year. And you've also got the fact that you've got 2 of these hydrogens that then form that. This isn't like necessarily balanced. I think if this was more accurate, you would actually have 2 of these purples, you would have 2 of these reds down here, and you would have 1, 2, 3, 4 of these whites over here. So if I was writing the book, I would actually design it like that. Okay, very quickly, questions. Let's go through them. What is the clue in the term endothermic and exothermic that indicates these are linked to heat energy? Pause the video. The answer is that both words have thermic in. What is the thermometer measuring in figures 2 and 3? Pause the video. It's measuring the temperature change in the surroundings of a reaction mixture. Okay. Question number 3. Why is an energy change evident that a chemical reaction has taken place? Pause the video. Well, when there is an energy change within a chemical reaction, the reason why you actually get that energy change is because not all of the bonds that are reforming are exactly the same as the bonds that you broke, and sometimes the number of bonds that you form are different to the number of bonds that you broke. So as a chemical reaction involves rearranging atoms, the type and number of bonds broken will not be the same as those that are made, and you do need energy to break bonds, and you do get more energy from making bonds. So at the end of the day, what happens is these two steps are not equal in size, and you will get an energy change in the surroundings. Either energy is going into the reaction or energy is being released to the surroundings out of the reaction. Potassium reacts with water in an exothermic reaction. What does this suggest about the energy needed to break the bonds compared with energy released when they are made? Pause the video. Well, it shows that the energy released is greater than the energy required, so this is an exothermic reaction. And finally, why are some reactions exothermic and some reactions endothermic if they both involve breaking bonds and then making bonds? Pause the video. So the answer is that not all bonds are the same. They can vary in how much energy is required to break or make them, and as a chemical reaction involves rearranging atoms, the type and number of bonds broken will not be the same as those that are made. Thank you very much. I did promise that it was going to be whistle stop. It's less than 10 minutes. Take care and good luck with your revision. And hope to see you in the next video. It should be 10.3. Bye for now.